Welcome to Programming Rainbow. In this video, we will be continuing on the series of the Beginner's Guide to SDL2 in Haskell. This is video number 5. If you would like to follow along with this video, you can go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in Haskell. You can clone that repository, move inside the directory, open up whatever text editor that you wish to use. I'll be using NVChad. It's a Neoven configuration. So this is what it'll look like. We have a bunch of directories over here, or folders. These are the code for each of the videos, and the actual code that we work with in the project is in the app folder. So this is main.hs. There's a main.hs in each one of these. So whatever video that you want to check out or see the code to, you can go in there. There's also an old version that I was using a different style of code. I was using IORef instead of the state T transformer. But I just left it there for everybody else to look at it if they want to see it. So again, since this is video number 5, we will be continuing on where we left off with in video number 4. So if you're just starting out with this one, you want to go to the video number 4 folder, copy that into the app directory, and you should be where we are right now. So in video 4, we changed the colors of the renderer and we set a icon. So let's just run that real quick. Okay, we have a window here. It has a title up here. It's got a background. It also has transparency of the background. We can press space and it changes colors. We have an icon loaded as well, but it's not shown on my specific window manager. So on this video, we will be adding text. So we're going to be loading a new module. That's going to be the SDL.Font. And we'll be loading text. So let's check that out. So on package.haskell.org, packages /SDL2 tac TTF. That's what I'm looking in right now. Let me just show you where. I'll just go back to the main. So this is the main landing point for SDL2 TTF. That's true type font. That's the module we're going to be adding today. If we go down here into SDL.Font, that's what the documentation I'm going to be covering. So a couple things that we should already recognize here is we're going to initialize this, and it doesn't take any options to initialize it. It's just initialize. And there is also a quit. So we can go ahead and set those up without too much thought, because it's going to very much look like the way it has looked before. So I'm going to change this right away to creating text. Okay, and now I'm going to move down to the SDL.init function that we have created. And right here, this is where we've set up SDL, where we've initialized SDL and also added to the add clean actions, the cleanup actions, we added the quit. And then we've also done the same thing with initializing the SDL.Image module. And we've added the SDL.Image.quit. So we're just going to add another one, and this one's going to be font. Let me just show you again that in this project, I have already added into packages YAML, I've already added SDL2 and SDL2 TTF, which is what you will need if you were making your own project, but since it's already here, we don't need to add it. And we've already been using image. Okay. And again, I get those numbers from up here. This is 2.13 version. If I go back to here, it shows me all the versions. The latest version is 2.13, so that's where that version in package YAML is coming from, which is right here, 2.13. Okay, so I'm going to close this package YAML. So this looks exactly like this first one here. I'm just going to yank this. Since we've already done this exact same thing before, I'm going to paste it here, and we just need to adjust, well, before we do anything else, sorry, we need to go up to the top here, and we need to import qualified font. SDL2 font. Okay. And now we can go down to where I added in an extra initialize down here. And now this isn't going to work for SDL because we qualified it SDL.Font. So we need to make this SDL.Font. And we are error initializing SDL2 font. And then for the quit, it's going to be also font. Okay, SDL font. Okay, it's not initialize all, it's just initialize. That was a specific thing for original SDL that we were initializing all the subsystems. For font, it's just initialize. And we can see that function name right here. So that's the function name we're doing. And again, everything is prepended with what we qualified this for when we imported it. So since we qualified it as SDL.Font, it's going to be SDL.Font initialize. And the same with quit, SDL.Font quit. So that should get us up and running. We can compile it and make sure we don't have any errors. And we are using this run safe run. So if it does throw an exception, we've already seen this if you're following along in the video, but this is the action I want it to run. This is the error message I want to give it to safe run. That's going to make sure that an exception wasn't thrown or safely shut down if it has. And this is the action that we are adding to the cleanup actions if this was successful. So let's stack run this. We're not going to see anything change, but I just want to make sure no error occurs. So no error has occurred, which is good. It doesn't mean it's perfect, but if an error would have occurred, then at least I would have known to look for that. Okay, so now a couple of things need to happen here. We need to make a font. You know what I'm going to do? I'm going to open up my other project, and we can just look at it for reference. We're going to make a font, then we're going to make a surface, then we're going to convert the surface to a texture. Okay, so yeah, we're going to make a font, we're going to make a surface, and then we're going to convert that texture to a surface. We're going to get a rectangle. Okay, so we'll just kind of sequence these. I am in font. Okay, so to make a font, we are going to use the load function, and it's going to take a path, which is just going to be a string for us. It's going to take a point size, and it's going to return a font. Okay, so I'm gonna hold this in a variable stuff. I'm going to define a name up here that's going to hold my point size for my font, and this is the code that I'm already using. So what I'm going to do is these are new definitions that we're going to create. I'm going to define a couple of things here: what the text is going to say at the end, what the color is, and what the point size is. So I'm kind of interested in this point size right now. I don't want to use a magic number in the code. I would rather have it be up above somewhere where I can edit it later or see what it is. So I want to define font size here up here instead of just sticking it in the function. So that's what I'm going to do. And this looks like it's a normal int. Let me just double check that. Yeah, it does say point size is just an int. A lot of these SDL modules use cint, not int, but this one just says it's an int, so that's fine. So I think the point size I'm using is 60. So I've already defined a couple definitions for different names here: window title, screen width. So I'm just going to add a new one down here. Say font size, and this is going to be an int. And I'm going to make it be 60. That's the size that I want. But again, you can change this very easily, so to whatever you want it to be. Okay, so I know I'm definitely going to need that. So what I'm going to do here is it was load. So I'm going to do it in load media. And the thing I'm returning is a font. In my head, it's just a font. It's not the actual text. We need to make a font first. And what we're going to be doing is loading a true type font, which is right here, Free Sans Bold TTF. So that's what we're doing in this step right here. So this is going to be, I'm going to call it font. And we're going to use safe run because it could throw an exception. Since this is an action that I'm sending into safe run, I want to encapsulate the whole thing into parentheses. So this is going to be SDL.Font, and then it was load. And let's see what we needed on that. For load, we need a path and a point size. Okay, so the path is first. And since it's in this fonts folder up here, that's relative path. So I'm going to use font Free Sans Bold.ttf. And then we need our point size, which we defined above as font size. Now, if this does throw an exception, we need a string as our error. So I'll say error creating font. Sounds good enough. That's fine, defined but not used. This is not right here. I accidentally put a comma in there. So if you have that comma, you need to remove it. Now, we also need to clean up this font. Now, I don't want to do, when I was loading in the surface here, in a prior video, when I loaded in a surface, I unloaded it right away. So I didn't put it into the add clean. And the reason why I did that is because I wasn't actually checking to see if this threw an exception or not. I was just using it directly. But since I could unload this right away too, but the problem is I have another step that I also need to check if it's going to throw an exception. So then it becomes a problem as when you unload this and did it unload correctly if there was an exception. So what I'm going to do is I'm just going to add it to the add cleanup. Even though I only use the font one time, I'm just going to add it to my add cleanup. Because there's this exception, then there's the next exception that could be thrown before I could actually free the font. And then there could be a situation where it doesn't get freed and I just want to use best practices. So I'm just going to add it right here and just let the program hold on to this font the whole time. So add clean, and let's see what that is called to clean up the font. So we have the load font here. It's free right here. This frees a font. Okay. So this is going to be SDL.Font. Okay. And it's free. And then what we're freeing is the font. Okay, so that gives us a font. Now we can make a text with that font. And what it actually does is it uses the font and it'll generate text with it, but it puts it on a surface, not a texture. So surfaces are software rendered and they're held in RAM. They're not accelerated on the GPU. Textures are held differently, and they're able to be accelerated. So for fonts, we create a text with the font and it creates it onto a surface. And then we can convert that surface to a texture. So that's what we're going to do. So it is 2 steps. So we're still in the SDL font module, and it's going to be something like, it's the blended one is what we want. It should have been something like create surface from text blended. It's a really long name in SDL, but here they just simplified it to blended. There's different ones you can use. You can use solid, you can use shade. And this talks about when you're creating the surface with the font, how nice is the curved edges of the font going to look like. And I'm going to use the blended one because it's going to give me the best look. Now it does say it's very slow here, but we're only doing this one time. When we create a surface and then create a texture from this, that's not going to be slow. That's going to be fast. It's just the creation of the text is slow. And it's going to be super fast for us. It's not going to be slow, but if you were doing it every single frame, it would be slow. But we're only going to do this one time. And then we're displaying that texture over and over again, which will be super fast. So don't worry about this part here where it says slow, because we're only doing it one time. So we're going to use this blended, and this is going to take a font. This is going to take a color, a text, and I think this is actual text. Yeah, this is of type text. So we're going to need to pack that. And it's going to return a surface. Okay, so we already have the font. I do want to make this color right here. And I do want to define a named variable that's going to hold this text as well. So I want to define something that's going to hold both of these. This one's pretty straightforward. It's just text. We just need to pack it. But the color one, let's look at that. So this color is a V4. So it's like vector 4. So this is going to go from 0 to 255 for the color for red, green, blue, and alpha channel. So it's just 4 of those together packed in a vector 4. And that's what our color is going to be. So it's pretty straightforward. And these numbers, I believe, only go from 0 to 255. That's probably what they mean by the word 8. Yeah, it's an 8-bit unsigned integer. Yeah. So an 8-bit unsigned integer can go from 0 to 255. So 255, 255, 255 would be white. And if we change this, this changes its transparency. So if we put it on 0, you wouldn't see it at all. If we put it on 128, it would be half transparent. If we put it on 255, it's completely opaque, as in you can't see through it at all. So this didn't matter for the renderer when we're playing with the color of the renderer, but it will matter here. But I do not want anything see-through, but we could play with this number. So what I'm going to do is I'm going to create this, and we also need a font text, the text that we want this font to actually create. And that's pretty basic. We've already covered this. We're just going to pack it because it's a text that turns this string into a text. Font text. And this is of type text. And we just want to say Haskell. But again, this is a string literal, and we need to pack it to make it a text. And I didn't use the language extension at the top, so I'm actually using pack. But if you're using the language extension at the top, you don't need to do that. So we have the text that we want to create, and we have the color. Font color. SDL font dot color. So this is going to be, again, just 4 numbers, which is red, green, blue, and alpha channel. So we can play with these to change them. And this is going to be an SDL v4. And I'm just going to put 255, 255, 5, and 255. And we do need a dot right here. Okay, so that does that. Now, the function to create this text is called blended. So blended takes a font, a color, and a text. So I'm going to go down here to load media again. Call it text. I'm going to use the same safe run. And it's going to be SDL font blended. It takes a font, was it font text color? Font color text. So we already have a font. We have a color, which is font color. And we have a text, which is font And if this fails, we will say error creating text, creating surface from, because that's what it's actually doing, is creating a surface. Okay. And if this does succeed, we could just add the cleanup to this. Since this is a surface, it's a free surface, just like we've seen in a prior video. So this will be normal SDL, and it'll be free surface, and the surface name is text. Now, I don't know if I called it text. I think I called it font surface. Font surface, yeah. I think that's a better name, because it's going to get confusing if I just called text. So font surf, font surf. So we've created this font. We have this surface. Now we need to convert this surface to a texture if we want to use it as a texture, which we do want to. We don't want to use things as surfaces. So to convert from a surface to a texture is not part of the font module. It's part of standard SDL. So we've already seen surfaces before, but we haven't converted one. So we should have a texture from surface. Let's see. There's free surface that we just used. Create texture from surface. This is the name of the function that we want to use. And this is going to take the renderer. So we need the render and a surface, and it's going to return us a texture. Save, run. So this will be SDL create texture from surface. And we need the render, which is just called renderer in this function already. And we need the surface, which is called font surf. And if this fails, something like are creating texture from surface. Okay. And we already know how to deal with this. If to clean it up, it's destroy texture right up here. So we can say add clean SDL destroy texture, and the name of the texture is text. Okay, so now at this point, if we haven't made any mistakes, there's no errors going on, we can just draw the text. Now it's going to look really ugly because what I'm going to do, I don't have a rectangle yet, so I'm going to use this nothing, where it's going to take the entire surface or the entire source image, which is not going to be very big, and it's going to stretch it to the entire destination, which is the window itself, the render, which is big. So it's going to make it look really ugly, but that's just fine. We're going to make a rectangle in a minute. So I just want to see this being drawn. So copy, render the same, and this one is text, but we do need to pull it out up above. And I'm going to use nothing. Right up here where we need to text equals game. And we haven't stored it in the game either, so that's good that we're doing this step by step, where I would have missed that. Did I call this just text? Probably. Game data. Okay, so this doesn't exist yet. We need to go up. Right here. Game text. And this is of type SDL texture. And now it's going to error that we're not returning down here in the media. We do need to return this. Close text. Okay, all the errors look like they've gone away. So now in our game loop, we are pulling this text out and we are drawing the text. But again, it's going to be really ugly, and we can make it look a little better by changing the size of the text and all that. But I just want to see it working, and then we're going to create the rectangle. So stack run. So we see this text is not good looking, and that's not because it's TrueType font. That's because I actually rendered a very small text and then stretched it very big. We could actually just change we could change this up here to like 300. And it's going to look a little better, but it'll still be wonky because we don't know the dimensions of it. We are going to just make a proper rectangle in a second. See, it looks better, but it's still stretched because, again, we don't know the dimensions, but it's just stretching it. So let's make a rectangle. I'm going to put this back to 60. So there are two ways to make a rectangle. Originally in my code that is on GitHub right now, before I've changed it, is actually querying a texture. But since there is two ways to do this, you can actually do it from a surface. And I'm definitely going to be working with textures later that I need to query a texture to get the dimensions for a rectangle. But since we do have the surface right here in this situation where we took a surface and converted it to a texture, we do have this surface. So I want to show the other way to get the dimensions to make a rectangle from the surface. So this is going to have a little bit unnecessary code for later ones because we could just get it from the texture every time, but this is just good to show. So originally, I'll just show real quick the code over here, what I'm talking about. So this was originally how I was getting how I was returning the rectangle. And this is a function down here called SDL.queryTexture. And this is how you get the width and the height out of a texture. But it's much simpler to just do this down here. You get the surface dimensions from a surface. But everything else that we're loading from now on is all going to load directly as a texture. So I always use this. But since we have this situation where the font where we have a surface, I just want to show this one off. So I just created this today. And for this video, we're not going to use this other one. We're going to use the simpler version so you can see both ways. Okay. So what am I talking about with this? Well, let's go to, so we have this rectangle here. And this rectangle is this point and then a V2 and a V2. And I thought the point was just a P. Here it is. Constructor is just P. Okay. That's a bit confusing. So the rectangle is going to be the kind of where the rectangle is, which is this vector 2. So it's the X and the Y coordinates of it. So it's going to be two numbers here, which is, say 0, 0 for the top left of the screen. And then this second vector 2 here is a width and a height. So we have that's why this one's the point, because this is the origin of your rectangle. Say for this box that I'm looking at right here, this box has a width, this box has a height, but in SDL games, the origin of this box is right here, the top left-hand corner. So this is going to be the point. So if this is, say, let's say it's 20 pixels in from the left, this is going to be 20, and say 150 down from the top. So it's going to be 20, 150, which is going to be here. So the point is a vector 2 of 20, 150. And then if this width is 100 and the height is 800 or something like that, this one over here will say 100, 800. So that is a rectangle. So basically they've made it look complicated, but it's just 4 numbers. It's an X and a Y and a width and a height. So we need this rectangle to properly draw our Haskell. Otherwise, it's stretched to the whole thing when we're using the nothing. Let me show you in the code. Because I'm using nothing down here when I render copy it. Right here, I'm using nothing for the source rectangle. So these are both the rectangles. This is the source. I'm using nothing for the source. That means it's taking the entire source. So that texture that we've created that says Haskell, I want to use the entire source of that, which is great. That means I get the whole, I don't just get the H in Haskell, I get the whole word, the whole texture that was created. But now the problem is I don't want that texture stretched to the entire screen or the entire renderer. I actually want it to be displayed correctly with its correct width and height. So this destination rectangle, I need to change this. Let's say Haskell is 200 by 100. I need this to say 200 by 100. And I also need to put where I want it. It's at 0, 0 or wherever. So we're interested in this rectangle right here. We need to create this. So I do need the width and the height of the actual texture or surface. And then I can just leave the other two at 0, 0. I don't really care. When we look at a surface here, we already have the surface width and the surface height inside this surface data type, right? But we can't access it directly. We can't just use surface H as a constructor. It won't let us. But there is a function for it, which is surface dimensions or something. Surface dimensions right here. So I can apply this to a surface and I will get out a vector2, which is going to give me the width and the height. So that gives me the width and the height, and then I can construct that rectangle from that. So this is what we're going to do. And I'm going to pull this out into its own function. Okay, and I think I call this rect from surface or something like that. And I'm going to put this above the load media because I'm going to be using it inside of load media. So for me, I just put it up here. It's easier for my brain to think about it. I don't think you have to put it here. So I'm going to say rect. And the reason why I'm calling it rect is because SDL calls it an SDL rect. I understand in Haskell they're calling it a rectangle. That's just, you know, for shortening the word up, and my brain thinks about it as an SDL rect. Rect from surface. So we need a surface and we need to return a rectangle. And when we return this rectangle is, I guess, a generic data type. We need to know what the rectangle actually needs to be using cint. So it's going to be SDL rectangle. And then we also need to put cint here because the point and the vector2s are both cint, or all four of the numbers in the vector2s, because there's two vector2s, they're all cint. So we need to do it this way. Rect from surface. So I want a surface. We're just going to call it surface. And it was that surface dimensions is what it was called. This is going to be coming back as a vector2. So let's go SDL v2. And I want width. Sorry. I know it's called surface W. So I'm just going to use that name. And this is SDL surface dimensions, and we're applying this to the surface. Okay, so, and we need to return a rect. And what it is it's going to have that point and then the two v2s inside of it. So it's going to be like SDL rectangle. And then it's going to have this SDL.p. That was a constructor for the point. And then this SDL.v2. This is the point. So I'm just going to leave this at 0, 0. Now the other one is the width and the height, which is the what we just got from the surface. And that's also an SDL v2. And I'm going to use the surface W for width and surface H for height. And can I just return this? See if I can just spell it. Oh, okay. And I keep spelling it wrong, huh? Missing the R's. This point should be in its own, not over here. That's not correct. Okay. Couldn't match expected type C int. The actual type. Oh, what did I did here? Oh, okay. I just totally screwed up the type annotation. Should be IO and the rect at the end. Okay, so we have this now, this function. So what we want to do is get a rectangle from our surface. So we're going to hold this rectangle in game data. It's actually going to move out of game data into the game state later. But I think for video number 5, it's just in game data because I'm not actually I'm not changing the state of it. So I'm going to put it in here. So this is going to be game text rect. And this is going to be SDL rectangle. And it needs to be C int. All right, C capital I. Okay. So we have the type now, and down. Now we can just put this, before I had it under the texture, but we don't need to. We can actually get the rectangle once we have the surface. So I'm just going to do that. I'm going to add it here. And it doesn't matter. You could put it either way, but originally I was getting the rectangle from the texture, so I had to create the texture first. But I have the, well, we can just put it down there anyway. It really doesn't matter. So we'll call this text rect. And safe. Run on this. So this one is going to be the function that we just made applied to the font surface. So it's going to be rect from surface applied to font surface. I will say error getting rect from surface, creating rectangle from surface. This rectangle is not on the, it's not something we needed to destroy. So there's no cleanup action on this rectangle. Okay, but we do need to add it down here or it'll complain. So game text rect equals text rect. Okay, now it's looking good. No complaints. So down here in our game loop, we need to pull this out too. Text rect. And remember this, the copy is taking a maybe. So down here, this is a just on the text, and it's on the destination one. The second one is the destination. So let's say just text rect. It does have to be in that wrapped in that just because the copy takes a maybe, and this is just a rectangle, not a just rectangle. So we need to do that. Okay, so let's see what this looks like now. We should have it in the top left-hand corner. Should say Haskell, its correct size. There we go. Okay, so what happens if we What happens if we make it a little transparent? I actually don't know, since we're going through the route of the font to the surface to the texture. It might not save whether it's transparent or not. Let's try it. And we can make it another color. Let's make it purple. So we'll just take away this. So we have red, no green, and then we have blue. Okay. See how, wait. Let's go to black. Let me try that again. Yeah, I think this is halfway transparent right now, because this purple color should be brighter than this. Let's make it more extreme so we can see it. Let's make it say 64 or 32. Oops. Oh yeah, definitely. Okay, so it's being transparent right now. That's why you can barely see it. Okay, so the transparency does just work there, and the color. As you see, we changed it to purple. And we could say it, we could, make it say something else if we change that. But let's just walk through what we did here, just so I didn't miss any points. So we have created, we've defined font text to be Haskell, which is a text. Font color, which is our vector 4 of red, green, blue, and alpha channel. Font size is going to be used as our point size later. That is point size as in not in Haskell, but just as in text. You have pixel size and point size. I believe this is going to be point size for this font. So we're setting it to size 60. We have a couple new items in our game data, which is a new texture and a new this rectangle cient. We do have to specify that it's a cient. And the rectangle is not something that you need to manage. All these other things, we're managing them. We have to destroy the window, the render, the textures. The rectangle, we do not. If you were doing this in C, these are heap allocated, and this is literally just a rectangle. It's just a struct. It's not on the heap. You don't have to destroy it. In Haskell, it looks like probably the same deal. We go down into init SDL, and we're initializing font, which is almost the same as the original one, except it's just to initialize, and it's in the qualified SDL font. And again, we've added that font up here as import qualified SDL font. So that's the only thing we needed to do there. And then in load media, we're creating a font. We're using the load. We have the location of the font, and we have the font size, which is 60 above. And then we are freeing the font. We are creating a surface from our font and some text. So this is the blended one, the nice looking one. And we're using the font, we're using the color, and the text that we want. So this font is what we created above. The color is defined as that vector 4 up above. That's all white right now. And the text is Haskell that we defined up above. And that's our error message. And the way we free a surface is with SDL free surface. Now that we have a surface, we can do two things with the surface. One is we can create a texture from the surface just by using create texture from surface, and we need the render and the surface. It returns a texture. And the way we destroy a texture is destroy texture and with the texture. And the way we create a rectangle from a surface is the function we defined above, where we are getting the dimensions. It's returning a vector 2 of width and height. I just named them these names because this is how they were defined in the documentation, even though you don't have access to them. And so this function applied to surface is returning the width and the height So I'm just pattern matching on it to get out those two. And we're just returning this rect, which is has this point that has a SDL vector 2. And I just put it as 0, 0. That means it shows up at the top left. And then the width and the height is what I was really interested in. So the texture, or so that the Haskell text gets displayed at its correct width and its correct height that we created. So that is what we got from the surface right here. So when we display this rectangle, it will be, when we display it down here, we can actually use that just text rect. We've pulled out the texture text and the rect from game data there, and we're using it here. In SDL, this would be render copy. We use copy, render, that's the texture. This is the source rectangle, and this is the destination rectangle. And this is the one that has our correct width and the height, so it gets displayed correctly. And it's also using the point. If we were to change the 0, 0, it would move around the screen, which is what we'll do in the next video. Okay, so I think that's everything. If you have any questions, just ask them below. Again, thanks for watching. Have a good day, and bye.